Good afternoon to all. Today we can discuss a problem in loop analysis in the subject electronic devices and circuits. The question is based on the super mesh problem. So super mesh means you will be having a current source in along with your potentials, that is the your voltage sources. So this is 24 volt. So see this, there are two current sources. One is 2 ampere and another one is 8 ampere. So your first equation, first step is you have to mark the loop currents. So I am marking the loop currents to be, so it is taken as I1, this is I2, and this is I3. Normally you will be taking in clockwise direction. I am following that. Okay. So according to this, first for super mesh analysis, before applying KVL, we should write the current equation. So first see this in this loop 3, you have only one current source, that is the current flowing through, that is I3. So what is the value of I3? The direction of the, see the direction of the I3. The I3 is opposite to the 2 ampere. So I3 is equal to -2. That is your first loop equation. Okay. Second, come to the 8 ampere source. The 8 ampere source is between loop 1 and loop 2. So what is the direction of that 8 ampere? It flows in the direction of I2, but for opposite direction in I1. So what is that equation stands for? I2 minus I1 equal to 8. That is your second equation. Okay. Next, you have to apply KVL by open circuiting. So that means you are going to consider 8 ampere and the 2 ampere to be open circuited. So you will be having 1 ohm, 3 ohm. This is open circuited. So plus or minus 24 volt here. This 4 ohm. Here it is I2 for these two. This is open circuited. And here it is I1. And this is again open circuited. The current flowing through this is in this direction I3. This is 1 ohm and this is 3 ohm. Now apply KVL to this. Apply KVL to this loop. That is combining loop 1 and loop 2, open circuiting the current source. So now what will be the loop equation? So -2 plus, that is the current direction across this I1. Based on that, the 24 volt is potential rise. So applying KVL means upon the potential rise is equal to potential drop. Remaining all are the resistor elements, definitely there will be potential drop. So across this 1 ohm, the current is I1 and I3. So I1 into I1 minus I3. Then across this 3 ohm, the current is I2 and I3. So it is plus 3 into I2 minus I3. And across the 4 ohm, only the current flows is I2. Now you rearrange the equations. So what are the equations? It is I1, 1 I1. So what is that? I1. And what is I2? There is 7 I2 and minus I3 minus 3 I3 becomes minus 4 I3 equal to 24. That is your third equation. So now can you take this from this second equation? Our aim is to find I2 because the question is power dissipated I1, I2, I3, but the power dissipated across 4 ohm. You can take this I2. Either you can take I2 as 8 plus I1 and you can find out the current I1 because I3 value is -2. So I1 plus 7 into 8 plus I1 minus 4 into I3 value is -2 is equal to 24. So I1 plus 8 sevens are 56 plus 7 I1 plus 4 twos are 8 minus into minus plus equal to 24. So 8 I1 plus 56 plus 8 becomes 64. equal to 24. So 8I1 equal to 24 minus 64 becomes minus 40. And the value of I1 equal to minus 40 by 8 becomes minus 5 ampere. Then can you find this I2 from this? Because I2 equal to 8 plus I1. So I2 equal to 8 plus I1. So minus 5. So what is the value of I2? It is equal to 3 ampere. So now we have found out all the currents I1, I2 and I3. So the question is power dissipated across 4 ohm. So what is the power dissipated across 4 ohm? It is power is I square R. What is the current flowing through this 4 ohm? I2. So it is I2 square into R. What is I2 square? 3 square into what is the value of R? It is 4. So 3 square is 9 into 4. So the power dissipated across 4 ohm is 9 4 so 36 watts. So this is your final answer. So this type of problem, if it is a super mesh analysis, you have to write the current equation first and then you have to proceed. Okay, so then you can apply normal mesh analysis, that is a KVL, and you can solve the other things to find your currents I1, I2 and I3. Example here is a 3 loop problem. Hope you have understand. Uh, Thank you.